Alright, what's up guys? So this is our first little review video on proofs. I'm just going to be working on a bunch of proofs for you so you can kind of see how we go out with this, okay, and how we do this a little bit more. This is what we did in class, and this is just a video of me explaining it maybe a little bit better, okay? So, I'm just going to work through all 10 proofs. Okay, note that you're not going to have to necessarily do this on a write out set 10 different proofs on a test. However, it's good to see the way we go about doing this. Okay, you review tomorrow or the day right before the test. Okay, this is we did this in class on Tuesday. The review on Wednesday will look more like what you're going to do on the test. However, I just want you to see and get used to seeing proofs written out all the way. Okay, and so maybe that might help you a little bit go through and understand how the proofs work. Okay, so our first proof here says, given that angle A and angle B are right angles, so angle A and angle B are right angles, we want to prove that angle A is congruent to angle B, which sounds pretty obvious, right? But so it's a short proof to get us there. Okay, there's no picture here, but we can think about two right angles, like let's see, A and B. It's pretty obvious that they're all congruent. This is what we call the right angle theorem. So here we go. I'm going to go to a different color here. So if angle A and angle B are right angles, so angle A and angle B are right angles, that's our given. Alright, if I know that angle A and angle B are right angles, then I know that the measure of angle A is equal to 90, and then the measure of angle B is also equal to 90. Okay, that's by the definition of a right angle. Awesome, right? The definition of right angle says that if an angle is a right angle, then their measures are 90. Next, so both measure of A and both measure of B are both equal to 90 degrees. So they're equal to each other by the transitive property. If you put substitution property as well, I will take it. Okay, I've changed my mind on this. Talked to some other geometry teachers. They say that either substitution or transitive property will work. However, I think the best way to say it is with transitive. However, if you put substitution, I will not count off. Okay. All right. So since they're both equal to 90, they have to be equal to each other. Okay. So measure of angle A is equal to measure of angle B. I call it by the transitive property. Now, I'm not there at my proof statement. I have one more step to say my two angles are congruent. Okay, if the two measures are equal, then the angles themselves are congruent by the definition of congruent angles. And that's it, we're done. I put these little dots at the end to show that we're done. Okay. Now, that wasn't too bad. This is number one. Let's do number two. Move this over. Alright, number two says, given that Q is the midpoint of PR, so let me draw that. So Q, let me go up a little bit with this. Okay, Q, excuse me, is the midpoint of PR. That's one given. We also know that QR segment QR is congruent to segment RS. We want to prove that segment PQ is congruent to segment RS. So if we look at our thing, we know that Q is the midpoint of PR, so it's right in the middle of PR right here. We know that QR and RS are congruent. We want to show that PQ and RS are congruent. So basically we want to show that this and this is congruent. Okay? So let's write down our first given. I'll use that first. Q is the midpoint of PR. That'll be my first statement. This is by given. Alright, now I think if I know that Q is the midpoint of PR, then I know since Q is directly in the middle of PR, that these two segments, PQ and QR, have to be congruent, meaning that their lengths are equal. So the next statement we will say is that PQ is equal to QR. That comes directly from the fact that Q is the midpoint of PR. So since I used statement 1, and statement 1 said that Q is the midpoint, this comes directly from the definition of midpoint. The definition of midpoint says that if a point is the midpoint of a segment, that it splits it into two segments with equal length, which is what we have right here. These are my two segments of equal length. Okay, now, cool. So I'm going to save this for later, okay? I'm going to use this in a little bit, alright? So we'll put a little star by it, because that's what I'm going to use a little bit later. Statement 3, I'm going to just go ahead and state my other given. So QR, segment QR, is congruent to segment RS. This is given. Now, I'm dealing with this one in terms of lengths, so let's go ahead and do this one in the other way as well. Okay. Let's see, this will be QR is equal to RS by the definition of congruent segments. Alright, step 5 now. Okay, look. I see that PQ is equal to QR. Right? But then so is RS. Since PQ and RS are both equal to QR, they have to be equal to each other. Okay? Since they're both, I'm using step 2 and step 4 to show this. So step 2 and step 4 both give me step 5, right? Okay, so by the transitive property tells me this. Or by substitution if you'd like that. But I'm going to put transitive. Okay, now, very close to what I want in my proof statement right here. I want to show that I know that if the two segments have the same length, then they are, of course, congruent. So, and this is by the definition of congruent segments again. Congruent segs, I like to write. And with that, we're done. And that's all we need for that proof. Alright, this was number 2. Let's go ahead and do number 3 now. So I'll move this down. Alright, here we go. Number 3. We don't really see any like these when we did the lesson, but they're actually a lot easier since we're done with some numbers, okay? Thought I'd give you some easier proofs in here to get us started since we're writing these ourselves. So, our givens are that angle 1 and angle 2 are supplementary. And we also know that the measure of angle 1 is equal to 68 degrees. Cool. We want to prove that the measure of angle 2 is equal to 112 degrees. Now this seems pretty obvious, okay? but we have to state it out altogether, okay? And get as a night. We're basically just solving the problem that if 1 is 68, then we want to show 2 is 112. All right, first statement. Angle 1 and angle 2 are supplementary. That's our given. All right, let's think about what do I know if two angles are supplementary? Well, I know that their measures add up to 180 degrees, and we write this like this. The measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. All right. The reason that I know this, I'm using statement 1 to get statement 2. Okay, the one that says that if two angles are supplementary, then their measures add up to 180. This is the definition of supplementary angles. Okay, that's just supplementary angles. Okay, now so I have this measure of angle 1, but I know what measure of angle 1 is in my other given. So let's go ahead and state that other given right now, right? The measure of angle 1 is equal to 68 degrees. Okay, that's just a given. Now, think about this. I'm trying to show the measure of angle 2 is 112. So, what if I take 68 and plug it in for measure of angle 1 here, and then that will allow me to do some subtraction, and I'll be able to get what my measure of angle 2 is. Okay, so that's my plan here. My next step is to sub in 68 degrees for the measure of angle 1. So 68 plus the measure of angle 2 is equal to 180 degrees. And this is by substitution. Alright, now, just like I'm solving a regular equation here, I'm going to subtract 68 from both sides. Okay? Doing that, I get the measure of angle 2 is equal to, so what's 180 minus 68? Of course it is 112 degrees. And this is by the subtraction property. And with that, we're done. Okay, that's number 3. Let's do number 4 now. Okay, I'm not giving a picture for number 4, but let's just try to go with what we know. Alright, if we can draw out a picture if we need one for number 4. So we're given that angle 1 and angle 2 are vertical angles. And we also know that the angle 1 is congruent to angle 3. We want to prove that angle 2 is congruent to angle 3. Okay, so let's just write this down. Let's write this down. So, statement 1, angle 1 and angle 2 are vertical angles. This is given. Next, so what do we know about vertical angles? I think vertical angles theorem. Vertical angles theorem tells me that if two angles are vertical angles, then they are congruent. So my next statement automatically in my brain is to say that angle 1 is congruent to angle 2 by the vertical angles theorem. Okay, now, I also know something about angle 1 from my other givens. Let's go ahead and state that right real quick, okay? Angle 1 is also congruent to angle 3 by our given. Okay, now, we'll hold the phone here. I probably can use the transitive property. Since both 2 and 3 are congruent to angle 1, angle 2 has to be congruent to angle 3. Alright, and that's by the transitive property. So is that what we were trying to show? Yes, that's our proof statement, and we are done. So there was no need for us to do this out and write out the measures, or the measure of angle 1 equals the measure of angle 2, because we have a transitive property of congruence. So we're allowed to just go ahead and do this all together like that, with the transitive property of congruence, which we just really need to state transitive property. So that's number 4. Okay, here we go, number 5. Going down here for number 5 on our next page. Okay, so number 5, we got this picture here. I got look something being bisected, so let's write it down. Okay, I know that ray JL bisects angle KJM, and I also know that the measure of angle KJL is equal to 35 degrees. I'm going to prove that the measure of angle LJM is also equal to 35 degrees. Okay, so let's look at our picture. If JL bisects angle KJM, that means that JL is splitting KJM directly in half. Okay, so basically, if I know that KJL is 35, I just want to show that this is also 35. Okay. However, it's pretty obvious we see that. However, we need to prove it. Okay. So it's asking us to do. So first, let's go ahead and write our first given. JL bisects angle KJM. And this is given. Now, step 2. So if I know that JL bisects angle KJM, I know that KJL and LJM are congruent, okay? Because if an angle bisector splits an angle into two congruent angles, basically splits it right down the middle, right in half. Okay, so my next statement is angle KJL is congruent to angle LJM. I hate when I use angles and L for in there with an angle, because this angle already looks like an L. So anyway, angle LJM. And now, I used statement 1 to tell me this. The fact that JL was an angle bisector is what allowed me to say that KJL was congruent to LJM. So this is by the definition of angle bisector. Alright, cool. Now, notice that my next two things that I'm dealing with both deal with their measures. So I'm probably going to need to write these two angles in terms of their measures. So, if those two angles are congruent, then their measures are equal. So our next statement will just be to say that the measure of angle KJL is equal to the measure of angle LJM. This is by the definition of congruent angles. Alright, now, cool. I know something about the measure of angle KJL, so let's go ahead and state that now. Since I've introduced it, let's go ahead and also say that. I know that the measure of angle KJL is equal to 35 degrees. Okay, this is given. Okay, now, step 5. Okay, since I know that KJL is 35 degrees, but I know that KJL is equal to LJM, okay, so this then tells me since KJL is 35 degrees, the measure of angle LJM is also equal to 35 degrees. So here's the deal. I'll take transitive or substitution. Okay, because you're basically substituting. I'll take either one. They both work. Okay, I'm sorry for being such a stickler about that. I've talked to other geometry teachers. It's okay. If that's the biggest problem you were having, then you can take a breath, because they're really not that big of a deal. And I'm sorry that I've made such a big deal about them. Okay, but we can see how it would be transitive, because both these two things are equal to the measure of angle KJL. So measure of angle LJM is equal to 35 degrees by transitive or substitution. And is that what we wanted to show? Of course it is. So we're done. Awesome. Moving on to number 6. So I didn't give you a picture, but I want to draw a picture for this one, okay? So I said M is the midpoint of LN, so I'm just going to go ahead and draw LN here, okay? It might help us out a little bit on this one. LN, and then M is the midpoint, so it's directly in the middle, okay? We also know that LM is 8. We want to show that LN is 16, so let's write our given. M is the midpoint of LN, and also that LM is equal to 8. We want to show that LN is equal to 16. This is very obvious, right? However, we need to show logically that this works. Okay, first statement, I'll write my first given, okay? M is the midpoint of LN. This is given. Now, if I know that M is the midpoint of LN, meaning it's directly in the middle, it splits LN into two congruent segments, meaning that LM and MN are equal. That's what the definition of midpoint tells me. And I know I'm probably going to be dealing with the definition of midpoint because I have the word midpoint here. Okay? LM equals MN by the definition of midpoint. Okay, now, next, I know something about LM though, right? I know it's equal to 8, so I'm going to go ahead and state that next since I've started talking about LM. LM is equal to 8 by given. Okay, now, step 4, MN has to be equal to 8, right? We're either substitution or transitive. Both of them work. Okay, now let's talk about our segment. All right, so if MN is equal to 8, all right, what do we know about the whole thing LN? LN is just equal to LM plus MN, correct? So I can say that what? LM plus MN equals LN. So my point of doing this, okay, I knew this. I want to relate, I need to get LM somewhere in my proof because that's what my proof statement dealt with. So I use the segment addition postulate to introduce LN. Okay, and this is, of course, the segment addition postulate. Or SAP, as I've been writing it. Okay, now we know that both LM and MN are 8, so in one step we can sub both of those in. 8 plus 8 equals LN. So this is a substitution. Okay, now let's just clean up this left side. 16 equals LN, which is almost what we want to show, right? This is just simplify. Now, in hindsight, I probably should have written statement 5 as Ln equals Ln plus Mn. However, it's fine. I just need to swap Ln and 16 on either side of the equal sign, and I can do that using the symmetric property. And with that, we're done. 8 steps, not bad. This was a little bit of a longer one, however, it's not a big deal. Not a big deal. Okay, that was number 6. Okay, number 7. There's a little triangle here, however, every side of a triangle is just a segment, so we can do stuff like that. We know about segments. Okay. So number 7 says that PQ is congruent to QR. So PQ, segment PQ is congruent to segment PR. QR is equal to 14, and then PR is also equal to 14. We want to show that PQ and PR are congruent. Okay, so let's kind of go about this, marking up our triangle a little bit. PQ and QR are congruent. I know that QR is 14, and then PR is 14. So think about that, okay? If I know that those are both 14, I'm going to say that PR is going to be congruent to those two. We'll see. Let's see how we get this. Let's go about doing it, all right? This is what I know so far. So, 1, segment PQ is congruent to segment PR by given. So, I'm dealing with these in terms of their lengths, so I'm going to go ahead and write this statement as their lengths being equal. I can do that by the definition of congruent segments. Alright, now, I've talked about PR. I know PR right here is 14. Right, this is just a given. So this shows you I don't really have to say my givens in order, do I? No. Okay. So if I know that PR is equal to 14, and but PQ is also equal to PR. If PR is 14, but PR is also equal to PQ, by the transitive or substitution, I know that PQ has to be equal to 14 by transitive or substitution. Okay, now I know my lastly was what I'm trying to show. PQ and PR are congruent. Oh, excuse me. Guys, back it up, back it up, back it up. Okay, here. I know I wrote my given down wrong. You'll have to excuse me. This should be QR. I was wondering why that was so easy. Okay. So, QR, PQ is equal to QR, so okay. There we go. PQ is equal to QR. Sorry. So PQ is equal to QR. So PR is equal to 14. PQ is equal to, so let me go back and fix this, okay? So we said that PR, alright, I can't use PR now. So going back. It's okay. I was on a roll, no mistakes whatsoever. Here we go. I'm not even going to fix this in the video. I'm going to let you sweat it out a little bit and figure it out on your own. And then hopefully, if you figured it out, and we're going to email me and stop watching. So, okay. Now, if you kept on going, that's good. So here we go. We're starting over. Now, I know PQ is equal to QR. Now this, I'm going to go ahead and state my second given. QR is equal to 14. Now, this tells me since both of those are PQ, since QR is equal to PQ and QR is also equal to 14, that PQ is equal to 14. Now, it would be really helpful if I could have drawn out, if I could have written my given down correctly. So this is by transitive or substitution. Now, remember, I'm trying to show that PQ and PR are the same. So they basically are. We know that my third given says that PR is equal to 14. And this is just given. So since PQ and PR are both equal to 14, PQ is equal to PR by transitive / substitution. Now the two segments whose lengths are equal, so step 7 would just be to say, since our proof statement is that PQ is congruent to PR by the definition of congruent segments. Alright, and there we're done. Sorry for that little bit of a mess up there, okay? Hope I didn't confuse you too bad. If you need me to redo that video for that one, number 7, I can go ahead and redo that for you. Just let me know, email me, and I'll send you a new video for that, okay? Okay, number 8. Almost done. Number 8 says that given that AC is equal to 2 times AB, we want to show that B is the midpoint of AC, of segment AC. So basically it's saying that the length of AC is equal to twice of this length of AB right here. Okay? So, first statement. Alright. One is given. Alright, I don't really know where to go from here. What I can say that I do know that this is a segment, right? So I know something about the two smaller segments that make up AC, right? So what about I say that AC is equal to what? AB plus BC. Okay. So basically my goal here is if B is the midpoint of AC, if I work backwards, I know that if B is the midpoint of AC, that's what I'm trying to show. I need to show first that AB is equal to BC. Okay, that's my goal here. And that's why I introduced BC by doing that. Okay, with the segment addition postulate, and that's going to allow me to get to where I want to be. Now, Both of these two things on the right are equal to AC. So 2AB is equal to AB plus BC. This is by transitive or substitution. Now, I want to say that AB is equal to BC. Because if I am able to say that, then I know that B is the midpoint of AC. So I can subtract AB from both sides to get that AB is equal to BC. Because 2AB minus an AB is going to be just 1AB. So, and it gets rid of it on the right, AB on the right side. So this is the subtraction property. Alright, now, since AB and BC are equal, and we know that B is somewhere along this segment, that B has to be directly in the middle. So B has to be the midpoint of AC. And this is, but we know this by the definition of midpoint. Awesome. Okay, 2 more to go. Here we go, guys. Number 9 and 10. This is number 8 right here. Okay, number 9, here we go. Alright, well, we'll do it on the right side this time. Here we go. So, number 9 says that PR, segment PR, bisects angle QPS. I see that bisects word. I'm probably going to be done with an angle bisector. I am actually. And then I also know that angle QPS is a right angle. We want to prove that the measure of angle RPS is equal to 45 degrees, which kind of makes sense. So if PR bisects angle QPS, so I have angle QPS right here, PR is bisecting it, I know that QPS is a right angle. If PR is splitting angle QPS, the right angle, in half, it forms two 45-degree angles. That's what we're trying to show, that RPS is 45. Okay, so 1, ray PR, this should be ray on your sheet, not segment. Ray PR bisects angle QPS, and this is by given. Okay, what this tells me is that the two angles it forms are congruent. Alright, so angle QPR is congruent to angle RPS by definition of angle bisector. One second. Okay, cool. The keyword bisects tells me I'm using angle definition of angle bisector. Now, I'm going to go ahead and state, since our proof statement deals with the measures, we're going to go ahead and state that the measure of angle QPR is equal to the measure of angle RPS by the definition of congruent angles. Okay, now, that's about all I can say with that. Next, we're going to move on to QPS, being a right angle. Or, yeah, we'll do that. There's a few different orders you can do with this, alright? We'll save this one for later, number 3, okay? Actually, I don't want to put an arrow, I'll put a star by it. This is given. So if I know the angle QPS, I know that the measure of angle QPS is equal to 90 degrees. That's by the definition of a right angle. Let me go up, okay. Okay, next. Alright, I'm trying to get RPS again. So, what do I know? I know that. Okay, here we go. So, now that QPR and RPS are equal, I want a statement that talks about QPR, RPS, and QPS all together. Look at our picture. QPR plus RPS equals QPS, right? By the angle addition postulate. So let's do that. Since I'm solving for RPS on my left hand side, I'm going to write it like this. The measure of angle QPR plus the measure of angle RPS equals the measure of angle QPS. This is by the angle addition postulate. And if we look at our picture, it makes sense. QPR plus RPS equals QPS. Now, let's plug in what we know. Okay, we can do a bunch of plugs in once. Alright, so first, I know that QPS is 90. I'm going to go ahead and plug this into 90 right here. What else do I know? I know that QPR and RPS are equal. So which one do I want to substitute in? Let's think about what our proof statement is. It's talking about RPS. So I want RPS on my left side. So I'm going to say, since QPR and RPS are equal, that the measure of angle RPS plus the measure of angle RPS is equal to 90. So I substituted in 90 for QPS and then RPS for QPR. You can see where I'm going with this, right? This is substitution. So 8. Now let's combine like terms. 2 times the measure of angle RPS is equal to 90. By simplify. Okay, and then divide both sides by 2. The measure of angle RPS is equal to 45 degrees by the division property. And that's where we want to be, so we're finished. That's number 9. Now lastly, we do number 10. I'm just going to go down for number 10, okay? No, I don't have enough room over there. Let me go. Let's bring it over here. I'm just going to have to go over a little bit. That's okay. Alright, number 10. says that over here, PS is equal to RT. The length of PS is equal to the length of RT. Oh goodness. And then also the length of PQ is equal to the length of ST. We want to show that QS is equal to the length of QS is equal to the length of RS. So look at our picture. PS is equal to RT. Okay, cool. We know that PQ is equal to ST. We want to show that QS and RS are equal. So we're probably going to be doing a lot of segment addition postulates here. So let's go. We'll break it down. It's cool. We got this. So PS is equal to RT by given. I'm going to go ahead and state my second given too, I guess. Yeah. PQ is equal to ST by given. Step 3. Okay. Now, PS. Let's write PS in terms of PQ and QS. So, PQ, oh, that looks terrible, plus QS is equal to PS. This is by the segment addition postulate. Okay. Alright, I've introduced QS, that's cool. I also need to introduce RS. So I can do another segment addition postulate, RS plus ST equals RT. Again, segment addition postulate. So PQ and QS give me PS, RS plus ST give me RT. Cool deal. Now let's do some substituting. Let's substitute into number 3 first. So my goal here is I'm trying to get some transitive property action going here. So I want RS and QS to be equal to each other. So I'm going to try to substitute in, how about PS, ooh. Alright, here, I'm going to take these two statements, okay, and plug them into this one. Okay, well we know. So I know that PQ is equal to ST, so ST, now PQ now becomes ST. I also know that PS is equal to RT, so this will become RT. And then I'm left with my QS right here, right? Okay, so all this plugs into step 3 and they all go right here. Okay? So basically, I guess you can say I'm doing like this. I'm using step 3, step 2, and step 1 to get step 5. Okay, so now 4 and 5, I know that both 4 and 5 are equal to RT, like the right side of them. Okay, so I'm using 4 and 5 to get my step 6, which is that I'm going to write the QS on the left side because you see my proof is there. So I'm going to say that ST plus QS is equal to RS plus ST. And excuse me, I did not fill in number 5, which is substitution. Step 6 now is transitive property. Okay, now I'm very close to saying QS is equal to RS. I'm going to subtract those STs from both sides, and I've got that QS is equal to RS by the subtraction property. And that's what we wanted to show, and we're done. Whew, that was fun. 15 minutes of proofs, guys, and I messed up in the middle of it. That's okay. All right, that's what we got. Here we go. So, thanks for watching. I hope this kind of helped open your eyes on how to do some proofs by yourself. If you have any questions, of course, please email me, and I hope you have a great night, guys. Thank you.